Welcome, my dear students. So this is the advanced lecture series for JEE. So in this situation, what I am going to discuss about the switching problem. So using capacitor circuit switching problem. So first of all, we understand what is the logic behind this problem, how to solve this, and then we will solve some interesting problem regarding this. Okay. So let us say this is the circuit. Yeah, initially this is a circuit. So initially the switch is connected with this point. So switch is one is activated and is connected over there. Okay. So now after some time, that means after charging is completed. So charging is completed means the capacitor is initially uncharged. So once it is fully charged, that means after t equals to infinite time, the switch is being shifted to the position number 2. Okay. So position number 2. So first of all, in this type of problem, you are asked to calculate what is the charge flown first of all, and corresponding to that, what is the heat generated. Okay, so both Q and H has to be calculated. So initially what you do, initial position of the switch. So you have to draw two diagram for this type of problem. So first you draw the initial position of the switch, that is at t equals to 0. Now once at t equals to 0, so initially the 2 microfarad is capacitor is connected to the 10-volt battery system. Okay, because the switch is 2.1. So that means this plate become negative, this plate become positive. So once the charge is fully developed inside the capacitor, I can say that this plate is 20 microcoulomb charge and here it is minus 20 microcoulomb charge. Okay, the initial position is understood. Now corresponding to that, now once we connect to position number 2, now this 2 microfarad battery, a 2 microfarad capacitor is connected within 2 battery. Okay, so one is the positive negative polarity, another is this side is positive, this side is negative. So these two battery are opposing each other. So equivalent battery system, can I write it with 10 minus 2, that is 8 volt. Okay, so I redraw this diagram by drawing. So this is the 2 microfarad capacitor connected with one battery, which is only 8 volt battery. Okay, so corresponding to that, what is the charge? So for this situation, the charge on the capacitor plate becomes, so this side is positive, this side is negative. Okay, so positive plate to negative plate, so charge is here 8 into 2 is 16 microcoulomb, here it is minus 16 microcoulomb. So first you draw the initial position, corresponding to draw the final position. So initially when the charge is 20 microcoulomb, so now I can calculate what is the initial energy of the capacitor. What is that energy? That is equals to half C into V square. C is 2 into V is 10. Okay, so that means 100 microcoulomb. So this is the initial energy. Similarly, the final energy, E final is how much? E final is equals to half C into V square. That means half C is how much? C is 2. But now the V becomes 64. V square is 8 square means 64. So it is 64 microjoule. It is 64 microjoule. So in this situation, so what is the charge flowing through the battery? So 20 microcoulomb is the initial charge. Now the 16 microcoulomb is the charge is left in the plate. So can I say that 4 microcoulomb charge has been flown through the capacitor plate? So in this direction, the 4 microcoulomb charge comes into through the battery. So charge is coming to the positive end of the battery. Positive end of the battery. How much? 4. So energy of the charge is being dropped. So work done by the battery is negative. Work done by battery is how much? So 4 microcoulomb into 8 with a negative sign. Minus 32 microjoule. So now we got the answer for work done by battery, energy initial, final. So what is the heat number? So heat is equals to, I am writing over here, heat is equals to how much? Work done by the battery, that is minus 32. Minus final energy. Final energy is how much? 64. And initial energy is 100. Okay. So if I solve this, that comes as 64 minus 100 is 36, this is 4. 4 microjoule. 4 microjoule is the heat generated inside the capacitor once I switch the position from 1 to 2. Okay. So that can also be solved as what is the Q number? What is the charge flowing through the battery is 4. Charge flowing through the battery is 4. So what we can do that heat has another answer, means alternative way I can calculate alternative way. So heat can be written as delta Q square by to C equivalent. Now here only one C is there, so I should write the C equivalent is how much? 2 times of 2, that is 4. And delta Q is what? That is the 4 number is the delta. So 16. So 16 by 4 means 4 microjoule. So I am getting the same answer with this concept also. So whenever you are calculating the heat, so you go through this method to calculate the heat as delta Q square by 2 C equivalent instead of going through this method. So that method is only applicable whenever I want to calculate the work done with the battery also. Okay. So here the charge is coming to the positive plate and then going to the negative plate. So positive plate charge is coming means energy is being reduced on the charge. Energy of charge is being reduced. So energy of charging reduced means work done the battery is negative. So minus 32. Okay. So accordingly you have to calculate this. So answer is 4 microjoule. Okay. So this is the way you should draw the two diagram, and based on that you can solve the switching type of problem. So now let us solve some of the numerical based on this concept. Okay. Let us say this is the initial circuit. After closing the switch, find the charge flown to the 1, 2 and 3. Also calculate the heat. Okay. So before closing, so initially the switch point 2 is open. So before closing, if I draw the circuit, so one circuit has to be drawn for the before closing. So before closing, this 10 and 2 are opposing each other. So can I say this is the 8 volt battery system only? 8 volt. Okay. And since this line is not there, wire is not connected. So 6 and 3, these two are capacitors which are connected in series. So I am simply saying that equivalent is basically 2 microfarad. So C equivalent is 2 microfarad. Okay. So this is the before closing the switch, that is the initial position. Now based on that, I understand that on this plate the charge will be 16. On this plate the charge will be minus 16. Okay. So this is the initial position. So after closing, so once I close the switch, then what happens? Then the entire system is there as it is. So here it is 10 volt. Then this is the line, and this is 6 microfarad battery, 6 microfarad capacitor, and then another 3 microfarad capacitor. Okay, so this is the final connection. So now I want to write the potential equation. So every time you try to draw the potential values, write the potential values, and accordingly you can calculate this number. Okay, if I say this is the 0 potential, so that will be also 0 potential. So this 0 means this is the 10 volt potential. Here this is 0 means this is the 2 volt potential. Okay, so that means here also 2, here also 10. So now I understand that for the 6 microfarad battery, a 6 microfarad capacitor, the potential difference is 10. So charge on this plate will be 60. On this plate is minus 60. Okay. So similarly, this 2 microfarad, the 3 microfarad capacitor is across 2 volt potential difference. So lower plate will be positively charged, so it should be 6, and here is minus 6. Okay. So I am not writing the microcoulomb every time. So this is understand that. So this is the charge. Okay. So correspondingly, now I can calculate what is the final charge. Okay. Final charge is 60 and minus 60 like this. So initially the capacitor, both the capacitor before closing. So can I say here also 16 is there, here also minus 16 is there, here also plus 16 is there, here also minus 16 is there. Okay, so this is the initial charge distribution. Initial charge distribution. So all the capacitors are arranged in series combination. So all the charges are same. That means 16, 16 always. Okay. So right. So now once we close the switch, now the charge is being distributed. So on this plate, initially the charge was 16. Now the charge on this plate is 60. So can I say that through this line, 44 microcoulomb charge has been flown? Okay, why 44? Because it is equals to 60 minus 16. Okay, so 44 is flowing through that particular point. Now, come to this point. So here, initially the charge is minus 16. Here the charge is plus 16 and here is minus 16. Because it is connected to the negative side of the battery, so it should be minus 16. Minus 16. So initially the charge on the lowermost plate is minus 16. Now the charge is plus 6. So that means total charge that flown through this line is 22. Why 22? Because minus 16 was initial charge. Now if we add minus 16 plus 22, that means becomes plus 6. So on this plate now the charge is plus 6. So corresponding to this point, so 44 is coming, 22 is also coming. So through this line how much charge has to be flown? It is 66. Okay, because through this line, 22 is coming. 22 is coming. Through the other line, 44 is coming. So net charge accumulated over here is 22 plus 44 is 66. So 66 should go from this to that direction. Okay, so towards left, the 66 amount of charge should flow. Okay, now I can calculate the initial energy and final energy. So initial energy of this system is EI. That should be equal to half C into V square. So C equivalent is half 2 into V square means 8 square. Means how much? 64 microjoule. So this is the initial energy. Now final energy has to be for this one. So this is one final EF1 and here it is another EF2. Okay. Now what is EF1? EF1 is equals to half C into V square. So here the V is how much? 10 volt. So this capacitor is under 10 volt potential difference. So can I write half C? C means 6 into V square means 10 square. So that means 100 into 6, 600 by 2 means 300 microjoule. So here the number is 300 microjoule. Now for this EF2 again half C V square. C is again 3 and V is now it is 2. 2 square means 4. Okay, 2 square means 4. So that means 6 microjoule. So these are the EF2 and EF1 numbers. So correspondingly what you can calculate that there are two batteries. So work done by the battery number. So let us say this is the battery number 1. So here I am getting work done by battery number 1. Here I am getting work done by battery number 2. Okay. So for work done by battery number 1, it should be equals to how much? It should be equals to 44 microcoulomb has been flown to the positive end. 44 is flowing to the positive end. So 44 into 10. That is 440. Okay, 440. Work done by the battery 2 is how much? That is equals to 22 is flowing from the positive end again. From the positive side, 22 is flowing. So 22 into 2, there is 44. So total work done on battery is 440 plus 44 means 484 microjoule. 484 microjoule. Okay. So correspondingly, what you can calculate the heat. So what is that heat? Heat number can be written as equals to work done battery is 484 minus initial final energy is how much? 306. 300 plus 6 is 306. 306 minus initial energy 64. Okay. If I simplify this, that number comes to be as 242 microjoule. So that will be your final answer. Okay. So you can calculate the heat once the circuit is being closed, and also you can calculate the total work done by the battery for individual two battery systems are there. Okay. So this is how you have to solve this type of problem. Now moving on to the next situation. So here again a connection is being made. Again you are asked to calculate the same situation. Once I close the switch, how much amount of charge is flowing and also the heat. So again you have to draw the before closing the switch situation. So before closing, so this 6 and 4 are again now favoring each other. Okay. Now this 6 and 4 are favoring each other, but 12 and 6. So this is the circuit. So this is the 12 microfarad capacitor. This is the 6 microfarad capacitor. Now we are connected with the two battery system, that is 6 volt and 4 volt. And these two are favoring each other, 6 volt, 4 volt. Okay. Now 12 and 6 means C equivalent is how much? So for 12 and 6, C equivalent initial situation, C equivalent is how much? C equivalent is equals to 72 by 18 means 4. So 4 is the initial equivalent capacity. So corresponding to that, what is the charge on the plate? Can I write C into V, C into V? So this side is plus 40. This side is minus 40. This side is plus 40 and this side is minus 40. So this is the initial charge. So first you draw the initial circuit and correspondingly analyze the charge on the plate. Now once you connect the switch, now you close the switch. So once I close the switch, now again you have to redraw the next circuit. Now what is that circuit? So there is 12 microfarad capacitor, then 6 microfarad capacitor. Now this is the line joining between the two circuit is this. Okay. So this is the circuit. What is there? So here it is 12, here it is 6, then this 6 in this 4. Now again you go for the potential approach. Potential approach. Now what is that potential approach? If I say this is the 4 potential, this is the 4 potential, then it should be 10 potential. Okay. Here also it is the potential will be 10. Now since it is 4, it is also 4. Now it is 4. means here I can say zero potential, so this is zero potential. Now I can identify what is the potential difference between each and every capacitor. So 12 minus 4 is 6. So here the charge will be plus 72, here will be minus 72. This 4 means 24 minus 24. Okay, so these are the charge distribution. Now initially on that plate, the 72, so if I identify this plate as this plate, so here the charge is 40 is there. Now the charge comes to 72. So can I say that 32 amount of charge is being flowing? So through this part, 32 microcoulomb charge flows. 32 microcoulomb. Why? Because final charge is 72, initial charge was 40. So similarly, so from this circuit, from this part, 32 microcoulomb flows. Now initially, the other plate is minus 40. So this plate is minus 40. Now it becomes minus 24. So that means some charge has to be added. So how much? That is the 16 charge has been added. So 40 minus 40 plus 16 means minus 24. So through this part, 16 charge flows, 16 microcoulomb. So for this point, so total charge flow is 48. Okay, 32 plus 16 is 48. So 42, 8 charge flow. So once I know the charge distribution, now I can calculate the initial energy, final energy. Okay, and you can calculate also the heat. Okay, so I am giving that part as your homework problem. So you calculate the initial energy for this system, final energy EF1, EF2, both these two number. Work done by battery, work done B1, work done B2. You can calculate all these numbers, and finally you can calculate the heat also. Okay. So I am leaving it for your homework, so you can finally solve this problem. Okay. So this is how you have to approach the problem. Initially you have to draw the circuit, then finally again you have to draw the circuit and take the potential approach to calculate the charge distribution on each and every plate. Now let us say I am going to the another problem. So this is the circuit, initial circuit was there. Initially the switch is connected to the point number 1. Now after the switch is being connected to point number 2. Okay. So for the initial situation, what I can say, the initially this 3 and this 3 will be in parallel combination. This 3 and this 3 will be parallel combination. So total capacity is 6. And with that 6, the 3 will be in series combination. With that 6, the 3 will be in series combination. So again, equivalent is 3. Equivalent is 2. So initial C equivalent for this system is 2. Okay. So that is charge flown from the battery is how much? If it is 2 equivalent, the charge flown from the battery, can I say it is 20 microcoulomb? So 20 microcoulomb is the charge flown through the battery. Okay. And what I can say that in this situation, that 20 microcoulomb charge is flowing through the battery. Now you are connecting the switch to point number 2. So once I connect the initially, once the charge is flowing, so now we can also mark the charge distribution also. So these two are in parallel combination, means here the charge will be plus 10, here will be minus 10. Here also charge will be plus 10, here will be minus 10. Okay. And here the two capacitance is there, so it should be plus 20, should be minus 10. Okay, so this is the initial charge on the each and every plate of the capacitor. Now what I can say that initially these are the charge. Now once I join the switch to position number 2, now let us draw the second diagram. Here I am drawing the second diagram. Now this is the circuit. Now the connection is with the point 2. Now I am connecting the point 2. So this is the circuit. Okay. And this is the 10 volt battery. 10 volt battery. So now for this particular system, now these two, 3 becomes in parallel combination. So here the charge will be how much? Here the charge will be, now it should be 10. Now here the charge will be plus 10. Here will be charge will be plus 10. There minus 10. There minus 10. Okay. And this capacitor, which is in series with the other one, now it becomes plus 20 or minus 20. So here it becomes, so it is 20 plus, here it will be minus 20 then. Okay. So this is the final charge distribution. Now initially the plate that is with minus 10, this plate is minus 10, now it becomes minus 20. So that means 10 charge flows through this path. 10 charge flows through this path. So now initially this is minus 10, this plate is minus 10, now it becomes plus 10. So that means 20 charge flows through this So 20 flow this. Okay. And initially it was plus 20, now become plus 10. So from this, another 10 should flow. So now it becomes charge balance. So 10 is coming, now 20 is going down. Okay. So now what you can calculate that in that situation, work done by the battery is how much? How much charge is being flowing? So through that battery, again 10 microcoulomb is coming. So 10 is flowing. So work done by battery is how much? 10 into 10, that is 100 microjoule. Okay, positive number. And initial energy and final energy of the capacitor, what you calculate that initial energy is this. So all the charges are equal. All the charges are already alternating with each other. So ultimately what you can say, initial energy of the capacitor system, that is equal to final energy of the capacitor system. Why? Because initial energy once we calculate, if we write the half C square formula or Q square by 2C formula, so Q square is 10 by 2C, if I write it initial, so first is 10 square by 2C means 2 into 3 plus again 10 square by 2 into 3 and another number is 20 square by 2 into 3 is the initial. Now finally the charge also remains same. Na? Here also the charge remains same. Only thing is that the charge will alter on each and every plate. But since I am using the capacitor of 3 microfarad each, so here also I can write 20 square by 2C is 3 plus 10 square by 2 into 3 plus 10 square by 2 into 3. So these two numbers are same. So what I can conclude that initial energy and final energy both are same. So heat is nothing but our work done by the battery. So how much? 100 microjoule. So that will be your answer then. Okay. So this is a typical problem where I am getting the EI and EA both are equal. I am getting EI and EA both are equal and correspondingly I calculate the work done by the battery. That gives the answer as the heat. Okay. So moving on to the next situation. So here there are different capacitors are there. Again, you are asked to calculate when the switch is shifted closed, find the charge flown through this part. Let us say, so this switch is being closed. Okay. So before connection, I am writing, so when the switch is open position, so I want to write what is the charge on each and every plate. Charge on each and every plate. So if I write, this is the 20 potential, this is the 20 potential. So this point is 20 also. That means this is also 20. This is 0 potential. This is 0 potential. That is 0. So across these three capacitors, the potential difference is 20. But across these two capacitors, there is no potential difference. So since there is no potential difference between these two capacitors, can I say the charge will be 0, 0, 0, 0, all 0. There is no charge. There is no potential difference. Now, across the three capacitors which are in series combination, so what is the equivalent for this? That should be equal to 5 by 3. So 5 by 3 is the equivalent for the system. So initially the charge will be 100 by 3 there. Then it should be minus 100 by 3. Then again plus 100 by 3. Minus 100 by 3. Then plus 100 by 3. And minus 100 by 3. So these are the charges on each and every capacitor when the switch is open position. Now the switch is being closed. Once the switch is being closed, now what happens? Now these are the capacitors 4, 5. So these are the capacitors. Okay. Now we connect it with 20 volt parallel system. Now the upper switch is closed. Upper switch is closed means this point they are connected with each other and this also connect. Okay, this is the connection. Now once the switch is being closed, so can I say now that 20 is the potential difference over here? Okay, 20 is the potential difference over here. Now here the potential is 0. Here 0. I cannot identify the potential over here. So mark at X. So here also it becomes X. Okay. Now it is 20. So if this point is 20. So this point is 20 also. Okay, this point is 20. So corresponding to this, if I redraw the circuit, so there are 5 capacitors, each are having different potential difference. Okay. So let us say I am giving the naming as, let us say the first capacitor, second, third, fourth and fifth. I want to draw the circuit equivalent for this. So the potential is, one point is potential is 20, another point potential is 0. In between there is one potential X. Okay. So now I want to draw the position of the first capacitor. First capacitor is between 20 and X. So draw a capacitor between 20 and X. Now second capacitor is between 20 and X, so it should be in parallel with that 20 into X. Okay. Third capacitor is between, third and fourth are between 20 and X. So third and fourth are between 20 and X. So this is one capacitor, this is another capacitor. Now fourth capacitor, third and fourth is over. Fifth capacitor is between X and 0. So this is the final circuit. This is the final circuit. Now again, you have to identify the value of X. So for identification of value of X, so what I can say that I identify the isolated plate system. Like the earlier situation, I identify the isolated plate system at this one, this plate, this plate, this plate, and that plate. Okay, let us say here the charge is Q1, here the charge is Q2, here the charge is Q3, and here the charge is Q4. So can I write Q1 plus Q2 plus Q3 plus Q4 equals to 0? Yes, I can write. So Q1 plus Q2 plus Q3 plus Q4 becomes 0. Now what is Q1? Q1 is basically 5 into X minus 20. 5 into X minus 20. Now Q2 is same, Q3 is also same. Q3 is same, Q2 is also same. But only thing is that for Q3, you should divide it by 2. Okay, I am writing it. So for Q2, it should be 5 into X minus 20. But Q3, for Q3, there are 2 capacitors, each of 5. Okay. So equivalent is 5 by 2. Equivalent for this system, equivalent is 5 by 2. So Q3 should be equals to how much? Divided by 2. So X minus 20 into 5 by 2. Now comes the Q4. So what is Q4? Q4 is the potential difference in X. So I write 5 into X. That is equals to 0. The solution of this will give the value of X. So once I calculate this number, so X becomes 100 by 7. So 100 by 7 is the potential at X location. Now once we find the 100 by 7 potential, now I can write what is the charge on each and every capacitor. So across the one capacitor, across the capacitor number 1, the potential difference 20 minus X. So Q1 should be equal to 200 by 7. So here the charge is 200 by 7. Here the charge is minus 200 by 7. Okay. Now again, for this capacitor, second capacitor, for the second capacitor, the potential difference again 20 minus X. 20 minus X. So again, it should be plus 200 by 7. This plate is plus 200 by 7 and this plate is minus 200 by 7. Got it? So you have to be very careful about the charge calculation. So once I calculate the charge, you also have to mark the positive and negatives. So once I mark this, what you can understand that at X point, so here the minus 200 by 7 charge is there and here the charge is plus 200 by 7. So that means through this point, so initially there is no charge. So what is the charge total comes? So minus 20, minus 200. So that means total amount of charge that flown through the upper circuit. Initially, you can understand that initially if I am considering only these two plates, this plate and this plate. Initially there is no charge on these two plates, 0 and 0. But once I close the switch, both of these two red plates are getting the charge as minus 200 by 7 and minus 200 by 7. So that means some amount of charge has to be taken out. So what is that? Minus 200 by 7, minus 200 by 7. You have to add those two numbers. That means 400 by 7 is the charge that flown through this. So that will be your answer. Okay. So this is the method by which you have to solve this type of problem where you have to be very careful about the charge distribution. Once I calculate the proper charge distribution, then only I can write the answer. Okay. Hope you understand this. Thanks for watching my video. If you like, please subscribe my channel.